Okay, welcome to Monday. Hey, if you're doing this in reverse order, the first thing you were supposed to have done is taken the quiz. So go back to the email for your classes and notice that I gave you two links, one for quiz and one for the class. So go ahead and click on the quiz and if you haven't taken it, take the quiz first, then come back to this lesson. All right, so now everyone's taken the quiz, yes? Okay. Uh, So let's go on to the homework. The homework over the weekend was 10.4a, was compound inequalities, your first lesson on it. As normal, I'm going to post the answers, you're going to grade your work, and then you're going to go to the Google Forms and write how many you missed. So there are the answers. Go ahead and pause the video and grade your work and answer question 1 on the Google Forms. Okay. Here's our calendar. We just took the quiz. We're ready for the class, the second part of 10.4b, and then we're motoring on. So it looks like we got, two weeks of this, and then we get to our Chapter 10 test. That'll be the next thing for a big grade. Remember, all the homeworks count as 10 points. All right, your homework, once again, will be another worksheet. And as always, you can print it out or you can do the work on a separate sheet of paper. Kind of entirely up to you at this point. I've had a number of emails from kids and parents saying, hey, am I supposed to be turning the homework in? The answer is no. I don't need pictures of it. I simply need you to answer that first question on the Google Forms. So obviously, I'm asking you to be a virtuous student and to actually do your homework. There is no check other than your personal honesty that you are doing your homework. So be a good and ethical student and be virtuous. All right, today's the second part of the compound inequalities. Yesterday, or the last class, I showed you this particular picture, just trying to point out that, for those of you that get this quickly and you're not paying much attention, bad things can happen. I need you to certainly pay attention in all classes, but especially on the ones where I'm dealing with brand new material, stuff that you haven't seen before. If your average attention gets you through the class, I need above average attention to get you through these classes. All right, so for basic objectives, it won't make much sense right now because you don't know what interval notation means. So today's lesson will seem, if you are just jumped ahead to the worksheet and you try to do it, it would seem like it's a very complicated thing. It turns out this is pretty simple. There's just a few basic rules. It basically uses your prior knowledge and a few basic rules to rewrite your answers in a new form. So we're talking about notations today. If we think about what we're dealing with, we're dealing with inequalities, and we've been solving these inequalities. For instance, this inequality, if I ask you to solve it, well, you'd subtract 2 from both sides, and you would get to that answer right there. That is the solution to the inequality. In fact, we would say that is the inequality. But remember, we have other ways of showing this answer or this result. The first one was our graph, and there's the graph of that solution to that inequality. So both x is less than 9 and the graph are both solutions to that inequality. Well, it turns out, for various reasons, we have a third way of writing the same answer. And I know immediately you're going to say, why do we need 3 ways? One, it's in computer programming. If you want to write answers to things, you certainly can't have a picture of a graph as an answer in a computer program. So one, there has to be a different method of showing answers. And this isn't just computer science reasons. There's also an easier, more concise way of writing the answer. And it's called interval notation. Interval notation. An interval notation is the way to show solutions. So it accomplishes the same as the graph, and it accomplishes the same as the actual solution, x is less than 9. It just does it in a different form. All right, so interval notation uses 3 types of symbols. The first symbol it uses, we'll write this down next slide, but for right now, just listen. It uses 3 types of symbols. The first symbol is parentheses. We've dealt with parentheses before. It also uses brackets. We've seen brackets before. And it also uses the infinity symbol, and we've seen the infinity symbol. Now, this says negative infinity and positive infinity. For positive infinity, we don't put a plus because we're lazy. We're efficient as mathematicians. We write the least amount that's necessary. Okay, so let's write this down. So what we're going to write down are these 3 types of symbols and the reason or when we actually write those symbols down. Okay, so type of paper, when to use the symbols. So the first symbol we're going to talk about is parentheses, parentheses. So I want you to write that. So it's open parentheses, a space, then a comma, then a space, then a closed parentheses. On the right there, it says that when you will use it. If you have an open circle, we know when we have open circles, that's when we have a less than or a greater than. Or if you have positive or negative infinity, you will use parentheses. Now, don't get hung up on like, I'm already confused, I'm not sure what you're saying. Let's just write this down. We'll get to some examples and then ask your question if you're confused. Okay, so parentheses we're going to use if we have an open circle, a less than, a greater than, or positive or negative infinity. Brackets. When will we use brackets? Brackets will look like this. An open bracket, a space, a comma, a space, and a closed bracket. All right, we will use brackets when we have a closed circle. That means less than or equal to or greater than or equal to. There is no, infinity is not involved in this. So just closed circles or less than or equal to, greater than or equal to. All right, one quick note. Notice on both examples, parentheses and brackets, we have a left bracket or a left parentheses, and we have a right bracket or a right parentheses. And here's the kicker. We're going to use either both or a combination of both. That means we could have a combination of parentheses and brackets, or brackets and parentheses, or just brackets. This sounds really confusing, right? It ends up being not confusing at all. It ends up being a pretty simple process. You're going to like today's class. Okay. Quick reminder for some students out there, negative infinity is very small numbers, right? And I said that any mathematician, I would lose my license if I said that to a mathematician. Remember, infinity is not a number. It is the basic concept that numbers continue to get smaller and smaller and smaller. You never get to the smallest possible number. They just keep getting smaller. You can always subtract one, and you get a smaller number. But negative infinity is located to the left of the number line, and positive infinity is located to the right. Once again, it's not a location. You don't ever get to infinity. You just keep getting further and further to the right, negative infinity, or further and further to the left. I said that backwards. Further and further to the left, negative infinity, further and further to the right, positive infinity. Okay. So we're just going to jump right in. I'm going to show you how this works. So this was the example I gave you before. There are two results to a solution. One says x is less than 9, and the other one with a graph says x is less than 9. Okay? And you've done both of those. So here's how interval notation. Interval notation will say exactly the same thing, just with brackets, parentheses, with positive and negative infinity. Okay, so here's how it works. First off, either looking at the inequality or the graph. Sometimes the graph is the easiest one to look at. We look at to the far left. Where is that red going to? Well, notice the red is going to negative infinity, right? It continues to get smaller and smaller and smaller and smaller. That's what the red arrow means. It means it continues, keeps going, never stops. So on the left side, we're going to negative infinity. How about on the right side? Where does the red stop? Well, the red stops at 9. Does everybody see that, where I'm getting that from? Like I said, it's easier to look at the graph than it is to look at the inequality. And, okay, bad news, you're going to have to be able to do both. Either if I give you the inequality, x is less than 9, or if I give you the graph, you're going to have to be able to write this. We'll do examples of both. Don't panic yet. All right, so I've got my two, and I can't say numbers, but I've got my two values, negative infinity on the left, 9 on the right. Why 9 on the right? Because that's where the red stops. The red stops at 9, and it goes all the way to negative infinity. Now we go to our rules. I'm going to do the left side first. On the left side, if you have infinity or negative infinity, you put a parentheses. Okay. On the right side, I have a 9, but that 9 is an open circle. Notice there's a less than symbol or an open circle, so I will also use a parentheses. So there, ladies and gentlemen, in yellow is interval notation. And what it really is the solution to that original inequality. Okay. X plus 2 is less than 11. Okay. All right, there you go. There's your first one. We'll do a bunch of these. Don't panic yet. All right, here's another one. This says z is greater than or equal to 6, and the graph says the solutions start at 6 and go upwards. So on the left side, how small do the solutions get? Well, the solutions start at 6. So on the left, they start at 6. Everybody understand what I mean by the starts at 6? Look at the graph. If I go from left to right, the first thing that's in red is 6. Okay, and where do the solutions stop? Well, they don't stop. They go all the way to infinity, right? That's what the arrow on that little red wiggly line means. It goes all the way to infinity. All right, so on the left side, I've got a 6, but it's a closed circle. So this time I'm not going to use parentheses. I'm going to use a bracket. But on the right side, I've got an infinity, so I need to use a parentheses. Remember, our rules stated that if we have infinity, we're going to use a parentheses. All right, so there's one where we have a combination of bracket and parentheses. All right, for those of you that I talked a little bit too fast there, rewind it, watch those two examples again. All right, let's do another one. Let's see, x is greater than or equal to negative 21. Now, some of you may have to actually make the graph of this in order to figure this out. For me, I'm just going to read it. I'm always going to read it from variable to number. It says the solutions, or x, is bigger than or equal to negative 21. So that means where do the solutions start? On the left side, they start at negative 21 because it says x is larger than or equal to negative 21, or the solutions are larger than or equal to negative 21. So if they're larger than negative 21, where do they stop? Well, they don't stop. They go to infinity. Okay, if you had drawn a graph of that, it would be visually obvious of why it would be that way. All right, on the left, what goes with the negative 21? Well, the negative 21 has a greater than or equal symbol, so I use a bracket. Well, infinity always gets a parentheses. Okay, kind of catching on? Makes sense? All right, let's do another one. It says n is less than 3. N is less than 3. Or the solutions are smaller than 3. If the solutions are smaller than 3, then on the left side, well, it's negative infinity, right? The solutions are smaller than 3. On the right side, they stop at 3. Infinity always gets a parentheses, 3. Well, 3 has a less than symbol on it. Therefore, it gets a parentheses, not a bracket. Kind of making sense? Kind of catching on? You're like, well, wait a minute, Mr. C, what about those ones that are compound inequalities that we did last night for homework or over the weekend for homework? Like this one. Here's an and compound inequality. So for an and, oh, by the way, we'll not be doing or compound inequalities for interval notation. You can, you just have to write two of them for it, but we won't be doing that today. All right, let's see. Here's an and compound inequality. So let's see, where do the solutions start? Well, the solutions start at 5 and they go all the way to 9. You see how easy that one is? We just got to figure out whether we want parentheses or brackets. Well, the 5 has a less than, so it gets a parentheses. The 9 has a less than or equal to, so it gets a bracket. So, and inequalities, or compound inequalities, are actually pretty simple to do. You don't even have to think about infinity. By the way, ands will not have infinity. It will always be two numbers. Okay. Now, whether or not they're brackets or parentheses or a combination of both depends upon the inequality itself. All right, you ready to do one by yourself? All right, try to get to the answer before I do. This isn't the next question on Google Forms, but try to get to the answer. Okay, let's see. It says G is smaller than or equal to 9. If G is smaller than 9, then the numbers that are smaller than 9, well, that'd be negative infinity. And then it goes all the way up to 9. So infinity always gets a parentheses, and 9, you got to look at the symbol. It's less than or equal to, it gets a bracket. Did you beat me to it? Did you get that? All right. For those of you that need more assistance, I'd go back. I just gave you 4 examples. I'm sorry, 5, wait, 1, 2, 3, 4, 5. I gave you 6 examples. Go through those 6 examples. Okay. For the rest of us, here are 3 questions. This is question number 2 on the Google Forms. In other words, it says, what are the answers to box 3? So you're going to write 3 different answers here. So go ahead and and you can type it straight into Google Forms. It'll be fine. So go ahead, pause the video, type in your answers, and then play the video, and let's check them. How'd you do? All right, in the first one it says H, or the solutions, are bigger than negative 23. Well, if the solutions are bigger than negative 23, that means they start at negative 23 and go to positive infinity. Infinity always gets a parentheses, and negative 23 had a greater than symbol or a less than symbol, therefore it also gets parentheses. The second one is a compound inequality. It's an and statement, so is the third one. And it just simply squeezes the two numbers, negative 6 and 19. Notice on both of those you have a less than or equal to and a less than or equal to, so we get 2 brackets. And on the last one, well, the negative 1 is a less than, so it gets a parentheses, and the 2 is a less than or equal to, so it gets a bracket. How'd you guys do? Yeah, this is pretty simple, isn't it? All right, for those of you that find this a bit more of a challenge, once again, I would rewatch the 6 examples. Hey, send me an email if you need assistance or extra help with these things. Moving on. Okay, now we're just going to do the reverse or the opposite. I'm going to give you the interval notation, and you're going to write the inequality. You're going to write the inequality. So on a separate sheet of paper or in your notes, write this down. Here are basically the steps involved. Okay, there are two different set of steps here. One says infinity and one says two numbers. This is the only two ways this can happen. You're either going to have an infinity symbol involved, positive or negative, in your compound or in your interval notation, or you're going to have two numbers and no infinity. Okay, and for each one, it's just slightly different steps. So go ahead and pause the video and write those two down. All right, for those of you who need an example, there's an example for one that has an infinity. Okay, you ready? So here's one that has an infinity. So we're going to follow the infinity rules, okay, because there's an infinity right there. It says pick a variable, any variable. Me, I'm lazy, I always pick x. And it says use the number. Notice there's only one number there, 2. Okay, so I put a 2 there. Then it says look at the brackets and parentheses. So I got a bracket around 2, and remember infinity always gets parentheses. So if I have a bracket around 2, that means less than or equal to or greater than or equal to. So let's read it from left to right, the compound inequality. It says 2 to positive infinity. So we're going from 2 and we're getting bigger. So that means the solutions are bigger than or equal to 2. Okay, does that make sense? All right, let's do another one with infinity. All right. So we pick a variable. It has two numbers. Here's one that has two numbers. These are the easy ones. All right, for the two numbers, it says pick a variable in the middle. So guess what? I always pick x. Look at the left number and make it the left number. Look at the right number, make it the right number. See what I mean by these are easier? Look at the one. It has open or close parentheses. It has, does it have a parentheses or a bracket? It has a parentheses. Therefore, it gets a less than symbol, not the less than or equal to. Okay? Look at the 7. It has a bracket, so it gets a less than or equal to. Okay? All right. One more. Let's do this one together. If you can do this before I do, put it on pause, get to an answer, and then play the video. For those of you that need assistance, let's do it together. So this one has a infinity symbol, so we're going to use the infinity rules. So it says pick a variable. Yeah, I pick x. Write the number 7. It has a bracket on 7, so that means it's going to be less than or equal to or greater than or equal to. So now let's see what it says. The interval notation says it goes from negative infinity to 7. So that means the solutions are all smaller than 7. If the infinity was on the other side, it would mean all the solutions are bigger than 7. So all the solutions are smaller than 7, therefore it gets a less than or equal to. Why not a less than? Because it's a bracket, not a parentheses. We got this? All right, some of you may need to hear all that again, so go ahead and play the last 4 examples. But for the rest of us, we're moving on, and here are two. This is the next question. I don't know if we're on box 3 or 4 of the Google Forms, or question 3 or 4 of the Google Forms, but it will say, what are the answers to box number 6? So go ahead and pause the video, write your two compound inequalities, write your two inequalities for those interval notation questions, and then play the video to check your work. Okay, so the first one is compound inequality since it has two numbers. So x goes in the middle, it's negative 2 on the left, 12 on the right, and I have a bracket and a bracket, so it's less than or equal to and less than or equal to. The second one, it's one of those infinity ones, so I have x. It's going to positive infinity, that means we're getting bigger, so that means x is going to be bigger than, what's the number? Negative 50, and since it's a bracket on the negative 50, it's greater than or equal to. So x is going to be bigger than or equal to negative 50. How'd you guys do? Okay. Well, it looks like we got 2 things left. So here's what they're going to ask you to do. They're going to give you a interval notation. They're going to ask you to make a graph of it. So they're going to give you this, and they're going to have you make a graph. It's kind of simple. So let's see. What's the information we have here? We know there's a 10 involved, so we need to write that number, 10. Notice it says write numbers, because remember, if it's a compound inequality, I'm going to have 2 numbers there. All right, so write number or numbers. There's only one, so put 10 in the middle. And then read the interval notation. It says it starts at negative infinity. So where are we going? We're going to negative infinity. Now, the only question is this an open or closed circle? Well, is it a parentheses or a bracket on the 10? It's a parentheses, so it gets an open circle, and we're going to negative infinity, so this one's even easier. We're going to negative infinity. There you go, and you're done. Let's see that again. I got two numbers, so I need two numbers on my number line. What two numbers do I need? Well, I need 2 and 9. Well, I'm not going to insult your intelligence and tell you which one needs to go on the left and which one should go on the right. Just remember, numbers get bigger as they go to the right. Do you need to put any more numbers? Yeah, if you want to, but 2 and 9 is all I need. All right. Let's see. What goes on the 2? Open or closed circle? Well, it's got a bracket, so it's closed circle. How about the 9? Open or closed? Yeah, parentheses, so an open circle. And then we simply shade in between. So the ones with two numbers, it's one of those and compound inequalities. Therefore, we always shade in between. You will not get an or today. Let's see this again. Ooh, we got a infinity involved. So all we need is one number, just that one number. Look at the 4. Is it got a parentheses or a bracket? It's got a parentheses, so that would be an open circle. And then we're going to positive infinity. So just shade to positive infinity and you're done. Wow, these are getting kind of easy. In fact, I don't think we need to do another example. You guys go ahead and do this one all by yourself. For those of you who need to rewind that and watch the 3 examples, please do. But for the rest of you, go ahead and pause the video, get to your answer. You're going to have to play the video because it's a graph to see if your answer matches my answer, okay? All right, let's see. I got two numbers, so I need a number line with two numbers. The two numbers are -1 and 5. I got two parentheses, so it's going to be open circle on both and shade in between. All right, so go ahead and answer on the Google form, did your graph look like my graph? Now, if yours had the numbers involved, like you had -1, 0, 1, 2, 3, 4, and then 5, yours looks like mine as well as 2. All right, we getting the hang of this? All right, one last thing. I said we weren't going to do an or. Well, we are going to do an or. All right, so let's see what an or looks like. So an or looks like, well, remember, there is no compound inequality with, without the word or. So it's going to have the word or, so guess what you got to do? Yeah, that's right. You got to make the inequalities, or you got to make the graph with the two inequalities together. All right. So we got to graph both of these on the same number line, So we just do the process twice, but all on the same number line. So you just got to be careful when you make your number line. There will be two numbers involved. Check it out. The two numbers for this one are 1 and 3. 1 and 3. So I need to have a 1 and a 3. Now we do each one separately. So notice on the top one it says it goes from -infinity to +1, and +1 has a what? It has a bracket, so therefore I need a closed circle on 1 and an open circle on 3 because 3 has a parentheses. Do you see that? Okay, so the 1 goes to -infinity, the 3 goes to positive infinity. These ors are pretty simple. Does that make sense? All right, go ahead and let's do the last one all by yourself. And once again, pause the video, get to an answer, and then play the video to see if your answer looks like mine, and then answer the last question on the Google Forms. Okay, so the first one, let's see, goes from -infinity to -4, and the second one goes from 20 to positive. So the two numbers I need are -4 and 20. Okay, let's see, it would be an open circle on -4 because it's got a parentheses, and it would be a closed circle on 20. And both of them, and you get the hang of these, how these works each and every time. Well, it seemed like we didn't do that much, but we actually did a lot today. So we did those 4 objectives right here. As always, send me an email. We got plenty of time to get this homework done, get it done correctly. Don't wait till the next class. Hey, I didn't get number 4. Shoot me an email and let me help you. Okay, so that concludes Monday's class, and I will see you guys on Wednesday.